Good morning, students. So in this class we are going to discuss biodegradation of xenobiotics. So xenobiotics are called as different compounds. Xeno means different. So biodegradation of different compounds. So in this category we will get certain organic compounds and certain aromatic compounds. So degradation of organic and certain aromatic compounds comes with category of xenobiotics. So we will see the degradation of halogenated aromatic compounds. Halogenated aromatic compounds. So if you see certain aromatic compounds like toluene and L-mandalate. So if you take the examples of toluene and L-mandalate, so toluene undergoes degradation to form benzyl alcohol, which in turn forms benzaldehyde, So degradation of toluene results in the formation of benzyl alcohol and in turn forms benzyl aldehyde. So this benzyl aldehyde in turn forms benzoate and ultimately results in formation of an intermediate form, that is catechol. So this is the degradation procedure for toluene. So toluene undergoes degradation to form benzyl alcohol, which in turn forms benzaldehyde, benzoate and finally catechol. Whereas mandalate, which forms the benzyl formate, which results in formation of catechol. So if you go for other aromatic compounds like anthracene, naphthalene, and phenaphthalene. So which undergoes degradation to form salicylic acid and which results in the formation of catechol. So anthracene, naphthalene and phenaphthalene will undergo degradation to form salicylic acid as an intermediate. So this salicylic acid will further degrades into catechol. So apart from this, other aromatic compounds like benzene and phenol undergoes degradation to form catechol. So overall, the degradation of aromatic compounds will result in the formation of a catechol as an intermediate. Next, if you go for degradation of organic compounds, so if you take examples quinate or quinols, p-hydroxymendolate, p-hydroxybenzyle formate, benzyl formate. So if you take certain examples of quinols and para-hydroxymendolate and para-hydroxybenzyl formate, quinate forms dihydroshikimate, this para-hydroxymendolate will form shikimic acid, para-hydroxybenzyl formate, which results in the formation of para-hydroxybenzaldehyde. So all these products will result in the formation of para-catechuate. So the degradation of organic compounds like quinols, para-hydroxymendolate, para-hydroxybenzyl formate, which results in the formation of different intermediate compounds like dihydroshikimate, shikimic acid, and para-hydroxybenzaldehyde, and finally which results in the formation of para-catechuate. So this catechol and para-catechuate will undergo further degradation to form other compounds by two methods, two pathways. Ortho cleavage pathway is one method, and meta cleavage pathway. Ortho cleavage pathway and meta cleavage pathway. So by these two methods, this intermediate catechol and para-catechuate will undergo further division. We will see ortho cleavage pathway. So catechol will undergo degradation to form cis-meconate, next meconolactone, which forms oxoadipate, oxoadipate lactone, which degrades to form acetyl-CoA, and succinyl-CoA. So catechol undergoes degradation to form cis-mucinate, mucinolactone, oxoadipate lactone, and acetyl-CoA and succinyl-CoA. Next, in orthocleavage pathway, the paracachuate it degrades to form carboxy cis-mucinate, carboxy mucinolactone, carboxy cis-mucinate, carboxy mucinolactone, which degrades to form oxoadipate lactone, and finally succinyl-CoA and acetyl-CoA. So this is about orthocleavage pathway. Orthocleavage pathway. So the catechol and paracachuate undergoes degradation to form an intermediate oxoadipate lactone with different intermediates like cis-mucinate, mucinolactone from catechol, and carboxy cis-mucinate, carboxy mucinolactone from oxoadipate lactone, which results in the formation of acetyl-CoA and succinyl-CoA. This is all about orthocleavage pathway. Next, metacleavage pathway. Catechol will undergo degradation to form hydroxymucinoic acid, hydroxymucinoic acid, next oxopentavulurate, and oxovulvarate, which results in the formation of pyruvic acid, and acetic acid. So in metacleavage pathway, catechol undergoes degradation to form hydroxymucinic acid, oxopentavulurate, oxovulvarate, and pyruvic acid, acetic acid. Next, coming to the paracachuate. Hydroxyformaldehyde, carboxypentonate, next oxovulvarate, and finally pyruvic acid. So in meta cleavage pathway, para-cachuate will undergo degradation to form hydroxyformaldehyde, carboxypentonate, oxovalerate and pyruvic acid. So this is all about biodegradation of xenobiotics, in which we have seen the examples of aromatic compounds and organic compounds. So once again we will revise. So in degradation of aromatic compounds, toluene and mendelate, which are called as halogenated aromatic compounds. So toluene undergoes degradation to form benzyl alcohol and further degrades to benzyl aldehyde and benzoate, finally which results in the formation of a catechol as an intermediate. Coming to the L-mendelate, which results in the formation of benzyl formate and finally catechol. And other aromatic compounds like anthracene, naphthalene and phenaphthalene, which results in the formation of salicylic acid and finally catechol. So benzene and phenol, which results in the formation of catechol. So overall, the degradation of aromatic compounds with results in the formation of catechol as an intermediate. Next, coming to the organic compounds like phenols, para-hydroxymendolate and para-hydroxyformate, that is dihydroshikimic acid and hydroxybenzaldehyde. These are the intermediates which forms from different organic compounds, finally which results in the formation of para-cachuate. So this catechol from aromatic compounds and para-cachuate from organic compounds will undergo further degradation by two pathways, ortho-cleavage pathway and meta-cleavage pathway. Ortho-cleavage pathway and meta-cleavage pathway. Catechol, mis-mucinate, mucinolactone and oxoadipate lactone. So catechol under ortho-cleavage pathway, which degrades to form cis-mucinate, mucinolactone and oxoadipate lactone as an intermediate. So from oxoadipate lactone, it results in the formation of succinyl CoA and acetyl CoA as end product. So from catechol to acetyl CoA and succinyl CoA. Coming to para-cachuate, so which results in the formation of carboxy cis-mucinate, carboxymucinolactone and finally oxoadipate lactone, which results in the formation of again acetyl CoA and succinyl CoA. So in ortho-cleavage pathway, the end products will be acetyl CoA and succinyl CoA from both catechol and para-cachuate. Next, coming to the meta-cleavage pathway, so the catechol undergoes degradation to form hydroxymuconic acid, oxopentabinolate, oxovalerate and finally with pyruvic acid and acetic acid. So that is from catechol. Next, coming to the para-cachuate, hydroxyformaldehyde, carboxypentonate, oxovalerate and finally pyruvic acid. So from meta-cleavage pathway, the catechol and para-cachuate will undergo degradation to form pyruvic acid as an end product. So in ortho-cleavage pathway, acetyl CoA and succinyl CoA as end product, whereas in meta-cleavage pathway it is pyruvic acid from both cachuate and para-cachuate and catechol. So this is all about degradation of organic and aromatic compounds. So we will once again revise it. Different compounds, the degradation of different compounds like organic and aromatic compounds comes with biodegradation of xenobiotics. So if you take the pathways of degradation of aromatic compounds and organic compounds, so if you take examples of toluene and mendolate. So toluene undergoes degradation to form benzyl alcohol, benzaldehyde and benzoate as an intermediates, finally catechol. Whereas L-mendolate which forms benzyl formate and to catechol. So from anthracene and naphthalene and phenolphthalein, salicylic acid will be formed. From salicylic acid it will result in the formation of catechol. From benzene and phenol there will be results of catechol. Whereas coming to the organic compound degradation, quinols, pyroxymendolate and para-hydroxybenzyl formate undergoes degradation to form several compounds like dihydroxyshikimate, shikimic acid and para-hydroxybenzaldehyde, finally which results in the formation of para-catechuate. So from aromatic compounds catechol will be formed, and from organic compounds para-catechuate will be formed. So these two will undergoes further division, further degradation to form further compounds. There are two ways, ortho cleavage pathway and meta cleavage pathway. So in ortho cleavage pathway, catechol will undergoes degradation from cis-mucinate, mucinolactone and oxoadipate lactone. So this oxoadipate lactone will further degrades to acetyl-CoA and succinyl-CoA. Next, coming to the para-catechuate, carboxy-cis-mucinate, carboxymucinolactone and oxoadipate lactone, which results finally in acetyl-CoA and succinyl-CoA. Next, meta cleavage pathway, catechol, para-hydroxymucinic acid, oxanopentavinolate and oxovalproate, which results in the formation of pyruvic acid and acetic acid. And from para-catechuate, hydroxyformaldehyde, carboxypentonate, oxovalproate and finally pyruvic acid. So here you have to remember the end products of ortho cleavage pathway and meta cleavage pathway. So in ortho cleavage pathway, pyruvic acid, acetyl-CoA and succinyl-CoA will be the end product from of ortho cleavage pathway, whereas in meta cleavage pathway both catechol and para-catechuate will result in the formation of pyruvic acid. So this is all about degradation of xenobiotics. So with this we have completed this topic.